again welcome you all on my YouTube channel, and today we will move forward in thermodynamics. Okay, so in the last video we have seen about the basic concepts in thermodynamics and the maximum terms that we are going to use in this chapter that we have covered in our first video. Okay, so in our first video we have seen about what is system, then what is surrounding, types of system, closed system, open system, isolated system. Then we have also seen about the extensive and the intensive properties of the system and the different thermodynamic processes like isothermal process, adiabatic process, isochoric process, isobaric process, reversible process. All these we have seen. Okay, today we will move ahead in thermodynamics, and today we are going to learn about the nature of work and heat. Okay, now in the last video I told you that while studying thermodynamics we are going to emphasize on a system which contains a gas. Okay, so in this video we will cover what is the type of work that such type of system does, and also what is the relation of heat and work. So in this video we are going to see how the work and heat are interrelated with each other and how does they affect the system, and especially the system which consists of a gas. Okay, so let's start with the first point, that is the nature of work. So first we are going to study about the nature of work. Okay, now we all know that the work done is force into displacement. These all we have studied in our lower classes, that work is force into displacement, and the requirement for the work done is that along with the force there should be a displacement. If I am applying a force to move a thing but the thing doesn't move, then I have not done any work. So in science the work is said to be done only when there is a displacement of that particular thing. So work is force into displacement. Okay, now but in case of thermodynamics, as I have said that in chemical thermodynamics we are going to learn about the system. We are going to learn about the system consisting of a gas and volume. Volume is nothing but, for any system, for any substance, its volume will be the volume is nothing but length into breadth into height. Okay, now whenever there is a movement of a gas from one phase to the other, means what, there is a displacement. Suppose this distance is suppose d. Okay, अगर गैस पे हमने प्रेशर अप्लाई किया, सपोज गैस यहाँ पर एक हमने एक बीकर ले लिया है, ठीक है, इस पे मैंने एक प्रेशर अप्लाई किया. ओके, यहाँ से ये इसके अंदर क्या है, suppose it consists of a gas. Now if I am applying a pressure over it, okay, then this piston will move in this direction. It will move in this direction, and now the amount of movement, suppose it has moved to a distance d. This piston, ये जो piston है वो suppose d की position तक के move हो गया. Means what, d is your here the distance travelled. Now this d is nothing but the length. Suppose this is square, then length into breadth into height will be again d into d into d. So the volume will be d into d into d, will be of the type. This can also be written as d cube. Okay. Similarly, if I want to say area, now volume is length into breadth into height, therefore it has come into d cube, and area is length into breadth. So in this case length is suppose d and breadth is also d, then this will become d square. This can be written as d square. Okay, now let us substitute these values in the expression. So now here we know that W is, that is the work done, is the force per unit area into volume. Yes, and per unit area, and area can be substituted as d square, into the volume can be written as d cube. Okay, so if I solve this, then this square and here square will get cancelled, and we get the answer as F into D. Means what, that again from here we have reached to this conclusion. Means the work done, that is force into area, can also be written as the work is equals to pressure into volume for a system consisting of a gas. So for a system consisting of a gas, the work done can be defined as the work done, W, can be written as the pressure into volume. Okay, have you understood this? Pressure into volume. So this is the nature of the work for a system consisting of a gas. Now we are going to see some examples using this expression. Okay, how will the gas performs the work? Okay, now again for the gas also the same rule follows. Work is the force into displacement. Now in case of gas, the force will be the pressure applied by the gas. Yes, गैस के केस में फोर्स क्या रहेगा? प्रेशर. जो प्रेशर गैस अप्लाई कर रही है या हम गैस के ऊपर अप्लाई कर रहे हैं, that will be the force that will be acting as a force. And here is the next is the displacement. Means in this case displacement means what? Whenever this gas applies a pressure and the volume of the gas will either increase, volume of gas either increases or decreases. Means what? Gas either expands or contracts. So that will be the displacement in this case. And therefore, for a system which consists of a gas, the work done will be nothing but the pressure and the volume. So, for a system consisting of a gas, work done will be pressure into volume. Yes? Let us see whether we are saying it right or not. Okay, so let us go backward and see whether really the work is equals to F and D. So, F and D should be equals to P into V. So, let us see that. Now, in this case, this is a pressure. Okay, and we know that pressure is nothing but the force per unit area. Yes, we know that pressure मतलब क्या है कि हमने कितना force लगाया और कितने surface पे लगाया है, means that area. So the force divided by area is nothing but the pressure. Now let us explore this work done as P into V for the two chemical reactions, because here we have to study about the chemical thermodynamics. So we have to apply this to a chemical reactions and we have to see what type of work is done then. Okay, so let's see that. So let's study the first chemical reaction, that is decomposition of H2o2, means hydrogen peroxide. Okay, so what will be the reaction? The reaction can be written as H2o2 will get converted into H2O liquid plus O2 gas. Okay, this is also in the liquid state. Okay, H2O2. Now let us balance this reaction. 2 and here it will be also 2 and 2, 4. Okay, now this will be the reaction. Now when if I am studying about the decomposition of hydrogen peroxide, now this hydrogen peroxide when react by itself only, it get converted into water and oxygen. Okay, now suppose here I have taken H2O2. Okay, this is my system. This is my system in which I have taken two containers. Okay, in which so this is my system in which I have taken a container which consists of H2O2, means I have taken hydrogen peroxide in this container. Now what will happen? This hydrogen peroxide, after a reaction get converted into water and oxygen. We know that it gets converted into water and oxygen. So now I have made an arrangement like this, that I have taken a H2O2 in this container, and to this container we have फिक्स्ड अ मूवेबल पिस्टन। मैंने आपको लास्ट वीडियो में भी बताया था, पिस्टन मतलब एक पंप की तरह होता है। आप जिस तरह हवा भरने का पंप आप लोगों ने देखा होगा, सो लाइक वो जो है पंप क्या काम कर रहा है, इट इज एक्टिंग एज अ पिस्टन। सो दैट टाइप ऑफ पिस्टन इज प्लेस्ड ओवर हियर। नाउ दिस पिस्टन हैज सम वेट ओवर इट। ओके, तो वो वेट क्या कर रहा है, इट इज कीपिंग द लिक्विड। सपोज इफ आई हैव टेकन b ml of liquid, okay? तो अब ये जो b ml of हाइड्रोजन पेरोक्साइड है, इसके ऊपर हम लोगों ने एक प्रेशर बना के रखा हुआ है, ठीक है? दिस पिस्टन इज अरेंज्ड ओवर इट. Now what will happen after some time, this hydrogen peroxide will get converted into water and oxygen gas. Means यहाँ पे water अलग हो जाएगा और oxygen gas produce होगी. तो अब ये जो गैस यहाँ प्रोड्यूस होगी, द गैस दैट विल बी गेट प्रोड्यूस्ड ओवर हियर, इट विल ट्राई टू पुश दिस पिस्टन इन द अपवर्ड डायरेक्शन, क्योंकि गैस को क्या लगती है, ज्यादा स्पेस लगती है, और स्पेस उसे यहाँ पर स्पेस नहीं मिल रही है बिकॉज पिस्टन इज ओवर देयर, वाटर इज देयर. अब वाटर में से अगर ऑक्सीजन को बाहर निकलना है तो इट विल रिक्वायर सम स्पेस. And to get that space, what will that oxygen do? It will push this piston upward. The piston will be moved in the upward direction. तो अब यहाँ पर क्या है? This is O2 gas and this is your water. ये दो चीजें यहाँ separate हो जाएगी after some time. This is your before the reaction has started. And once the reaction get complete, so this is the final result after the reaction. Okay, when the two the reactions get completed, so this water and oxygen will get separated. अब ये oxygen ने क्या किया है? It had moved the piston in the upward direction. Now this is a system. Okay, अब ये system क्या कर रहा है? This system is applying the using its energy. System के पास अपनी जो energy है उसको use करके वो क्या कर रहा है? It is applying a pressure in the opposite direction to move this piston in the upward direction. Okay, means in this case energy will be consumed by the system. यहाँ पर किसकी energy consumed होगी? System की energy consume होगी. अब ये जो system की energy consume हुई, किस बात के लिए consume हुई? In order to apply the pressure. Pressure apply हुआ, और प्रेशर अप्लाई होने के बाद हमारा क्या है, यहाँ पर डिस्प्लेसमेंट हुआ या नहीं, तो यहाँ डिस्प्लेसमेंट भी हो गया. दिस पिस्टन हैज गेट डिस्प्लेस्ड फ्रॉम दिस पोजीशन. ये थी उसकी इनिशियल पोजीशन और ये है उसकी फाइनल पोजीशन. मींस ये जो डिस्टेंस d है, दिस हैज बीन ट्रैवल्ड बाय द piston. So means what, this gas has moved. The volume जो था आपका यहाँ इनिशियल वॉल्यूम सपोज v था, तो अब यहाँ पे क्या हो गया, पूरा कंटेनर का वॉल्यूम V1 suppose हो गया. Means what? In this case, the pressure has been applied as well as the gas has moved the piston. Means there had been a displacement and the increase in the volume of the gas. So this is a pressure into volume type of work. अब यहाँ इसको हम क्या कहेंगे? That the system has done the work on the surrounding. So in this case, what has happened? The work is done. Work is done. Why work is done? Because the pressure has been applied and there is a change in the volume. So in this case, this system is performing the work. And it is performing the work means what? It is consuming the energy. The energy given by the system, the energy is consumed by the system and this energy is given to the surrounding. जब यहाँ पर energy, यहाँ से कुछ एनर्जी निकल रही है बिकॉज इट इज यूजिंग द एनर्जी टू परफॉर्म द वर्क, तो ये जो सिस्टम है वो एनर्जी दे रहा है. किसको दे रहा है? जब वो परफॉर्म कर रहा है, वर्क डन में जो भी एनर्जी यूज हो रही है, जो भी एनर्जी उसकी खत्म हो रही है, वो कहाँ जा रही है? बाहर सराउंडिंग को मिल रही है. ये कैसे? तो इसके लिए सिंपल एग्जांपल आप लोग अपने डेली लाइफ में देखते हो. क्या करती है आपकी मॉम? योर मॉम प्रिपेयर्स द फूड. ओके, अब वो जब खाना बना रही है उसकी एनर्जी लूज हो रही है. यस, एनर्जी लूज हो रही है एंड वो खाना जब आप खा रहे हो, सपोज आप सराउंडिंग है एंड योर मम्मा इज द सिस्टम. ओके, सो इन दिस केस दिस इज द सिस्टम एंड in your case your mother is system and you are the surrounding. So when your mama's cook the food, what happens? Her energy get wasted or her energy gets used, and that energy is given to you in the form of food. मतलब सिस्टम से जो एनर्जी निकल रही है वो कहाँ जा रही है? सराउंडिंग पे. और अगर सराउंडिंग कुछ वर्क करता है तो एनर्जी किसे मिलेगी? सिस्टम को. सो इन दिस केस द वाइस वर्सा टेक्स प्लेस. व्हेनेवर द एनर्जी इज गिवन बाय द सिस्टम, इट गोज टू द surrounding, and if the surrounding performs some work, then the energy will be given to the system. Okay, have you understood this much? So this is a type of work done whenever the expansion of the gas takes place. Expansion of gas takes place, then the work is done. Okay, let us see one more example, and that is of the ammonia. Reacting with the hydrogen chloride to form the ammonium chloride. Let us see that example also. Okay. Now let's see the second example, that is the reaction between the ammonia gas and the HCl gas. Okay. Now in this case I have taken again the same type of the container, and in this container I have taken the HCl gas and the ammonia gas. Okay. I have taken two gases, ammonia gas and HCl gas. Now what will happen? When this ammonia gas reacts with the hydrochloric gas, then we know that what is formed? Ammonium chloride, which is solid in state. Okay. So when these two gases react with each other, it forms the solid. Now अब यहाँ पे क्या होगा देखो. This is a mixture of ammonia and HCl gas. Okay, I know you cannot see the gas, but let us assume that this green color are the molecules of the gas. Okay, so here is the ammonia gas and the HCl gas. Now what will happen? Now let us emphasize on the second, that is the nature of the heat. Okay, up till now we have seen about the nature of work. Now let's see the nature of heat. Heat का nature क्या है? Okay. So as we have seen in our previous video, क्या अगर हम एक simple example लेते हैं, that if I am taking a hot cup of tea, okay, I am placing this hot cup of tea in just over the normal room temperature. ठीक है? After 15 minutes or after 20 minutes, what will happen? This tea will get cold. Okay, cold कितनी होगी वो? जितना हमारा सराउंडिंग का टेम्परेचर है उतना ही इस सिस्टम का टेम्परेचर हो जाएगा. मतलब क्या हुआ है? दिस हॉट कप ऑफ टी, सपोज आई एम टेकिंग दिस हॉट कप ऑफ टी. अगर ये मैंने बोल दिया कि दिस इज माय हॉट कप ऑफ टी, जिसमें से हॉट है एकदम. ओके, नाउ दिस हॉट कप ऑफ टी, व्हाट इज हैपनिंग आफ्टर द 15 मिनट्स. अगर 15 मिनट्स या 5 मिनट्स से ले लेते हैं तो क्या होगा? नाउ the temperature will be much lower, and how much lower? It will be of the room temperature. जितना भी आपका रूम टेम्परेचर है उतना ही टेम्परेचर इस टी का हो जाएगा. मतलब क्या हुआ है यहाँ पर? This is your system, this is your surrounding. The system has given heat to the surrounding. Now in this case the system has given heat to the सराउंडिंग. अब कब तक के वो एनर्जी एक्सचेंज चालू रहा? जब तक के दोनों का टेम्परेचर जो है वो सेम नहीं हो जाता, तब तक के ये हीट ट्रांसफर का प्रोसेस चलता रहा. और अगर हम अपोजिट ले, सपोज इफ आई एम टेकिंग एन आइसक्रीम. ओके, सपोज इफ आई एम टेकिंग एन आइसक्रीम. नाउ दिस आइसक्रीम, इफ आई एम कीपिंग इट ओवर अ रूम टेम्परेचर, अगर मैं इसको रूम टेम्परेचर पे रख देती हूँ तो क्या हो जाएगा? ये इट विल गेट मेल्टेड. It will get melted. Means what? In this case, the heat transfer has been taken from the surrounding to the system. Okay. So in this case, heat will be transferred. Means what? The energy is transferred from surrounding to the system. Whereas in this case, the energy is exchanged from the system to the surrounding. And this heat in thermodynamics, it is expressed as Q. The heat it will be expressed as Q. The amount of heat absorbed or amount of heat given, that will be expressed in terms of Q. Okay. अब एक important चीज जो हम इस पूरे सिस्टम में देखेंगे. अब हम बार बार every time we are not going to see that the work is done by the system or the surrounding, or the work is done by the surrounding to the over the system. या the exchange of heat has taken from the system to the surrounding या from the surrounding to the system, इस तरह से हम इनको नहीं करेंगे. इनको हम क्या करेंगे? We are going to give some sign convention, sign. Now these sign conventions will tell us whether the work is done by the system over the surrounding or by the surrounding over the system. Yeah, the heat exchange is taking from the system to the surrounding or from the surrounding to the system. So every time we are not going to say like this. Only these sign conventions that we are going to learn now, these sign conventions will tell us what type of work is done, from where the work energy is getting exchanged. That is all given by the sign conventions. So let us see that sign conventions. Okay, so let us see over here. Now let me consider one system. Okay, this is my suppose system, and I have said that system is your mummy. ओके यहाँ पे याद रखना हमेशा. हमें सिंपल याद नहीं आता है कभी कभी कि प्लस डब्ल्यू क्या है, माइनस डब्ल्यू क्या है, प्लस क्यू क्या है, माइनस क्यू क्या है, ये जो हम अभी देखने वाले. तो उसके लिए क्या याद रखना है कि सिस्टम मतलब मम्मा. ओके, अब देखते हैं. अब सिस्टम, ओके, सिस्टम अगर वर्क कर रहा है, मतलब सिस्टम अगर आपका जो मम्मा है वो क्या कर रही है, इफ शी इज प्रिपेयरिंग द फूड मीन्स शी इज, उसकी एनर्जी यूज हो रही है, और वो एनर्जी किसे मिल रही है, आपको मिल रही है. आपने वो खाना खा लिया, आपको एनर्जी मिल गई, मतलब आप एक सराउंडिंग हो और मम्मा एक सिस्टम है. तो अब ये जो सिस्टम है, जब भी इस सिस्टम से वर्क, सिस्टम जब भी वर्क करेगा, मतलब सिस्टम से अगर हम सराउंडिंग की तरफ जाएंगे, whenever the work is done by the system over the surrounding, then it is denoted by minus W. मम्मी की एनर्जी जा रही है इसलिए माइनस. Whenever the system is doing the work over the surrounding, it is minus W. And if अगर आपने एक दिन खाना बना लिया मम्मा के लिए, okay, means your energy is getting transferred to the system, means the surrounding is performing the work on the system. तो उस वक्त मम्मा की एनर्जी बढ़ जाएगी. एवरी टाइम मम्मा की एनर्जी यूज हो रही है, therefore whenever the work is done by the system, ये याद रखना है कि मम्मा निगेटिव आ गया मतलब मम्मा की एनर्जी चली गई, पॉजिटिव आ गया मतलब मम्मा की एनर्जी आ गई, एंड मम्मा मीन्स सिस्टम. सो सिस्टम अगर काम करेगा तो एनर्जी लूज होगी, एंड इन दैट केस the sign will be minus. And whenever the work is done by the surrounding over the system, then it will be, the work done will be plus W work. Means एक दिन आपने अगर खाना बना दिया, सराउंडिंग ने अगर खाना बना लिया और मम्मा को खिलाया, तो that will be, अब यहाँ पे मम्मा की एनर्जी बढ़ गई, means what, positive energy. Okay, similarly heat transfer. अब heat transfer is denoted by, I have said that heat transfer is denoted by Q and work done is denoted by W. Okay, so whenever the work is done on the system, then it will be plus W, and whenever the work is done by the system, then negative minus W. ठीक है. Similarly heat. अब heat कितने इसमें क्या होगा, if the heat is given to the system, okay, if the heat is given to the system, मतलब heat क्या है, एक form of energy है. yes, heat अगर system के पास आ रही है मतलब energy add हो रही है, and therefore it is denoted by plus Q. okay, so in this case energy in the form of heat, यहाँ पे हम ले लेंगे heat energy. okay, heat energy is given to the system, then it will be denoted by plus Q. okay, it is denoted by plus Q. And if the heat is given by the system, means if the system is losing its heat, then the energy will be loosened, and then in that case if the heat is coming out, means the energy has been given by the system in the form of heat, then it will be denoted by minus Q. So in this case the energy which is in the form of heat is taken from the system. Okay, So whenever the heat energy is from the surrounding to the system, then plus Q, from the system to the surrounding minus Q, work done over the system plus W and work done by the system minus W. Okay, so इसके बाद हम every time by the system to the surrounding ये सब ने यूज करेंगे. Plus W है मतलब क्या है? The work is done over the system. Minus W means work is done by the system. System काम कर रहा है और energy surrounding को मिल रही है और यहाँ पर work is done by the surrounding and energy is given to the system. Okay, have you understood this much? Okay, so let's move to the next topic, that is expression of pressure volume, expression for the pressure volume work. Let us derive an expression for the pressure volume work. For this, I have taken one cylinder and in this cylinder I have taken a gas and this gas has suppose the pressure P. Okay, over this cylinder I have fitted one piston. This piston can be moved in both the direction, means it can be moved up in the upward and the lower direction. Okay, now if I want to expand this gas, okay, means if I want to move this piston in the upward direction, तो मुझे क्या करना पड़ेगा? फोर्स अप्लाई करना पड़ेगा. कितना फोर्स अप्लाई करना पड़ेगा? अब यहाँ क्या हो रहा है? एवरी टाइम्स द एटमॉस्फेयर, ये जो बाहर का जो सराउंडिंग है आपका, जिसको हम बोलेंगे एटमॉस्फेयर, दिस एटमॉस्फेयर इज ऑल्सो अप्लाइंग अ प्रेशर. एटमॉस्फेयर भी अपना एक प्रेशर, एटमॉस्फेयर की वजह से भी यहाँ पर एक प्रेशर डेवलप हो रहा है जिसको हम बोलेंगे एटमॉस्फेरिक प्रेशर. ओके, तो ये जो एक्सटर्नल प्रेशर है जो कि हमको बाहर एटमॉस्फेयर क्रिएट कर रहा है, उसको हम लोग बोल देते हैं पी एक्सटर्नल. सो जब ये प्रेशर, जब यहाँ पर ये गैस इस एक्सटर्नल प्रेशर को अपोज करने में कामयाब रहेगी, तभी यहाँ पर क्या होगा? ये पिस्टन अपवर्ड डायरेक्शन में मूव होगा. यस, ये जो पी एक्सटर्नल प्रेशर है, अगर बाहर एटमॉस्फेयर का प्रेशर और आपका सिस्टम का प्रेशर दोनों अगर सेम है तो देयर विल बी नो मूवमेंट इन द पिस्टन. बट इफ आई वांट टू मूव दिस पिस्टन, देन द lower pressure means the pressure applied by the system should be little bit greater. जब ये pressure greater रहेगा तभी क्या होगा? Piston will move in the upward direction. So suppose this is your that external pressure. Okay, तो अब अगर इस piston को move करना है और इस piston का surface area suppose है A. Okay, so in this case we know that the force that will be required to move this piston will be your P external into A, pressure into the surface area. Pressure into surface area हमारा हो गया force. अब this pressure is same as the pressure applied by the gas. एकदम छोटा सा ही फर्क है, लगभग सेम ही है. So and but in this case the pressure is to be moved in the opposite direction. ये जो external pressure है, जब ये surrounding से system पे आ रहा है तब उस पे पॉजिटिव साइन है. बट अगर हम इस एक्सटर्नल प्रेशर को अपोज कर रहे हैं, मींस इट हैज बिकम नेगेटिव. सो इन दिस केस फोर्स कितना हो जाएगा मेरा? पी एक्सटर्नल इनटू ए, एंड नेगेटिव साइन इंप्लाइज दैट द फोर्स इज अप्लाइड बाय द सिस्टम ओवर द सराउंडिंग. ओके, नाउ अब अगर वर्क डन, अब इस केस में सिस्टम अगर वर्क डन कर रहा है, देन वी नो दैट वर्क डन इज गिवन एज force into displacement. Now in this case this force is nothing but P external into A. So I can write W is equals to P external negative sign into A into D. Yes, I can write like this. Now this A into D, A into D क्या हो जाएगा? This is the surface area into, suppose this here is this distance traveled by the piston. पिस्टन यहाँ से यहाँ तक मूव हो गया, ये सपोज डी डायरेक्शन है, तो ये जो एरिया है इनटू डी, ये क्या बन जाएगा? वॉल्यूम ऑफ द गैस. सो इन दिस केस दिस विल बी P into A. Now in this case A into D is nothing but the change in the volume. ये क्योंकि चेंज इन द वॉल्यूम क्यों बोल रहे हैं हम लोग? क्योंकि इनिशियल वॉल्यूम आपका ये सपोज V1 था, यहाँ तक कि जब गैस थी तब V1 था. अब ये गैस क्या हो गई? ये एक्सपांड होके पिस्टन को इसने मूव कर दिया एंड इट हैज obtained a new volume, that is suppose V2. So if we combine these two equations, if we combine this first into this These two equations, if we are going to combine, this is your equation 1, this is your equation 2, this is your equation 3. Okay, now we know that A into D, since here we can write, since A into D is nothing but the change in the volume. So if we combine these two equations, then we get W will be equals to P external into delta V. And delta V is nothing but V2 minus V1. V2 minus V1. अब ये जो केस है ये डिसाइड करेगा whether the system, whether जो the work is done by the system or the surrounding. अब कैसे कर देखते हैं, देखो. Now delta V is equals to V2 minus V1. Now in this case, since the gas is expanding, V2 is higher than V1. V वॉल्यूम बड़ा है और ये वॉल्यूम छोटा है, मतलब V2 minus V1 का जो आंसर रहेगा वो क्या रहेगा, पॉजिटिव आंसर रहेगा. यस, तो W की जो वैल्यू है दैट विल बी P एक्सटर्नल इनटू डेल्टा V. अब डेल्टा V पॉजिटिव, प्रेशर इज पॉजिटिव और ये एक निगेटिव साइन है, मतलब W क्या हो गया, निगेटिव हो गया. मींस द वर्क डन, यहाँ पर क्या हो गया, वर्क डन निगेटिव हो गया. वर्क डन अगर निगेटिव है मतलब क्या हो गया, किसने वर्क किया है, वर्क इज डन बाय द सिस्टम. अभी हम लोगों ने थोड़ी देर पहले देखा था. यस, सो इन दिस केस द वर्क इज डन बाय द सिस्टम. अब सेम केस अगर अपोजिट हो जाए, मतलब ये पिस्टन को मैं यहाँ ना मूव करते हुए, अब ये क्या हो जाएगा, सपोज अगर इसको, ये पिस्टन नीचे मूव हो रहा है, मतलब अगर आपकी जो गैस है वो सपोज कॉन्ट्रैक्ट हो गई, means the piston this is your suppose the new position of the piston, means in this case the displacement is over here and this V2 is over here. Okay, so in this case V1 is higher than V2, means V1 in this case is greater than V2. Therefore delta V, that is V2 minus V1 क्या बन जाएगा, यहाँ पे V2 छोटा है और छोटे में से हम बड़े को माइनस करेंगे तो आंसर विल बी नेगेटिव. एंड W is nothing but P external into delta V with a negative sign. So this will is also negative. So minus P external into ये भी एक negative हो जाएगा. तो negative negative will become positive. So the work done will be positive. मतलब W कैसा हो गया मेरा, plus W. तो अगर plus W है इसका मतलब क्या है, the work is done by the surrounding over the system. Work is done on the system. वर्क सिस्टम के ऊपर हो रहा है, मीन्स कौन कर रहा है, सराउंडिंग कर रहा है. So in this way this expression can be used to find out whether the work is done by the system or work is done on the system. Means the energy exchange has taken from the system or by the system. Okay, so this is an expression for the pressure volume work. This is very important expression and it will help you to solve many numericals in the further case. Okay, now one more thing I want to ask you, whether if the work is done in vacuum, अगर कोई सराउंडिंग ही ना हो, ठीक है, एक केस हम ऐसा लेते हैं कि अगर सराउंडिंग ही नहीं है तो जो वर्क डन है अगर वैक्यूम में हो रहा है तो क्या वो वर्क डन रहेगा. इफ द फ्री एक्सपांशन विदाउट, अगर सराउंडिंग ही नहीं है तो सराउंडिंग नहीं है मतलब क्या रहेगा, एटमॉस्फेरिक प्रेशर कुछ रहेगा क्या, नहीं, अपोजिंग फोर्स कुछ है ही नहीं, सिर्फ सिस्टम ही अपना एक्सपांड हो रहा है. तो इन दैट केस वेदर द वर्क विल बी डन और नॉट. सो व्हाट डू यू से, सो इन दैट केस देयर द एक्सटर्नल प्रेशर इज जीरो, कोई अपोजिंग फोर्स है ही नहीं. तो अगर ये चीज जीरो हो गई तो जीरो इंटू एनीथिंग विल बी जीरो. सो व्हेनेवर द वर्क इज डन इन द वैक्यूम, the work is said to be work is not done. Actually in that case the W is zero. No work is done in the vacuum. Vacuum में कोई work नहीं done रहेगा because there is no opposing force. Opposing force होना जरूरी है work done के लिए. No opposing force. Okay? Have you understood this much? So today we have seen about the nature of heat and work, and we have seen about the expression between the pressure volume type of the work. We are having many examples to solve over this, so that we will see in our next video. Okay, if you have any queries regarding this topic, you may ask me in my comment box. And till then, thank you. Bye bye. you.